Network failures are common in Jetpack Compose. Most of the Jetpack Compose apps show blank screen or infinite loader. The root cause of this is UI state not being modeled properly. In today's video, we'll show a production-ready app which handles error plus retry UI. We will fix retry logic the correct way without breaking the recomposition in Jetpack Compose. This is a perfect example on how you should not handle UI state inside a composable function. So here we have two state variables. One is loading, which is holding a Boolean value and by default the state is true. The other one is error message and it is holding a nullable string and the default value is null. So on the first glance, as you can see, this code should work fine since we have a launch effect here triggering the fetch data from our repository and which is also inside a try catch, and after the repository call we are also updating the isLoading state to false, and also if there is any error we are also catching an error here, and inside our when block if it's loading true we are showing a circular progress indicator, and if error message is not null, inside a column we are showing the error message along with a button to retry. Now let's run the app and check if it's working. So I'll run the app here. Let me pull up my emulator. Let's check if it works. As you can see, the state is just loading. Now, could be one of the two reasons. Maybe this API fetch data throwed an exception, and on exception we are not handling the Boolean state of isLoading, or maybe the recomposition of the state is causing the issue. Under the hood we never know. Let me go ahead and handle the case here as well. In case if we face any exception, we should update the loading state to false as well. Let's see what happens. Okay, app relaunched and let's see. So we can see it went to an exception and it updated the isLoading Boolean to false, which is good. And now let's retry using the retry button. So if I call the API again and the composable goes back into infinite loading state. So why this issue happens? First thing is UI doesn't know what state it's in. No clear error representation here. The retry logic usually triggers multiple calls. The UI is now stuck in infinite loading because state is inconsistent. Retry here is tied to a recomposition, not an intent. The composable is deciding when to call the network. Compose reruns the function, so this logic breaks. Let's fix this by modeling UI state explicitly and moving the logic out of the composable. To handle the UI states in Jetpack Compose, we should always use sealed classes. So for example, I have created a sealed class here of UI naming UI state, and it has object of loading, a data class of success, a data class of error. This is perfect example to handle UI states. The key point here is that we are avoiding Boolean flags. The state is explicit. The UI reacts to the state, not to the logic, any of the logic. And once state is correct, your UI becomes predictable. This is screen state holder class. This holds the UI state of the screen, which we saw earlier. We have created our own UI state, which holds either loading, success, or error state. And we are creating a mutable out of it, and we are holding the state of it. And we also have a small function to load data. This function is using our fake repository here to mimic the data, which is either fetched from the local database or an API. And we are also catching the exception of repository directly here. Using a screen state holder inside a composable brings lots of benefit. The network logic is outside of composable. The UI only observes the state, and composable function should never decide when to call the network. For example, on recompose, a composable should not call the API to collect the data. Now let's utilize and implement our screen state holder inside our composable function, and let's see how it works. So here, as you can see, I have a state holder variable for screen state holder, and I've also created a coroutine scope which will be used later on. So, and on launch effect, I'm calling the state holder load data, which will eventually call our repository and fetch the data. And inside the one block, we are watching the current state of state holder, which is our UI state. Now, inside our UI state, we are holding only three states. Either it can be loading, success, or an error. So for loading, we are showing a loading view here, and for success we'll be showing success view, and on error we'll be showing an error view. So let me just quickly show you what we are showing inside all of these views. These are just composable function. For loading, we are just showing the circular progress indicator, and for success we are showing the data with a text, and on error we are showing a text with a retry button, and retry button is calling this callback lambda, and on the callback we are using the scope and launching the load data again. So here retry is not auto triggered on recomposition, rather retry is user driven if user wants to retry to load the data. Let's run the app and check if it works. So app is running and it's loading, and we are getting a network error. Please try again. Let's identify the error. So if we go inside our repository, fake repository, so on the first load we are explicitly failing the API to check how our states are reacting in case if there is any failure. Okay, so if let me just go ahead and rerun the application. Okay, on the first load it should give us an error, which is true. If you see the if condition here, we are updating the Boolean value to false. That means on retry here we should get some data loaded successfully. So our composable is reacting to UI state and showing the predictable UI. So this is how we should use UI states inside composable. And we should also avoid common mistake often done by developers, which is calling API inside composable, retrying automatically on recomposition, Boolean flags inside of UI states, mixing UI and business logic inside a composable, which is a not good practice. So we have fixed the recomposition under the hood issues using the state holder, and we are also reacting to the state inside our composable. Still, this code is not lifecycle safe yet. So in the next video, I'll be adding vModel based UI state. If you like this video, do subscribe to my channel for more content and videos like this. And this was today's Programming Daily Dose.